Welcome back to my channel, and in this video we are going to solve this JEE advanced mathematics problem. This is a very complicated looking problem, but it is not complicated. It is a very easy problem. Always read a problem with calm mind and don't rush things. We're going to solve this problem and you're going to see how easy this problem is. It looks very complicated, like you have three sets and all those things, but it is very easy to do this problem. So always skim through questions, look at the question if you have an idea if you can do it or not, and this is also a multiple answer question. So even if you can solve one of the option and see can I see if one of the equation is true. So always try to do that. Read the question and look at the option, what can you do and how much you can do. So never look at the problem, never judge the problem by just looking at the problem. If you see so many expression, that is what they're trying to do. They're trying to scare you, but you are smarter than them. You're gonna read the problem and see, you're gonna find out how easy this problem is. So let's go and do the problem. So let's first read the problem and then we will solve the problem. Okay, so they have given you three sets which S, T1 and T2. You need to, and they're giving you some statement and you need to find which statement or statements are true. Okay, so now let's look at the first. So we need to find out that the Z union with T1 and T2 is still a subset of this S. Okay, so you can see Z is clearly a subset because if you put B is equal to 0, that A is still belong to S and A is basically an integer. So we can see that Z, which is an integer, is clearly a subset of S. Now we're going to check T1. To check T1 and T2, we're going to need help of sum of binomial. So let's see. See if I can write T1 and if I can write T1 and T2 in terms of how S looks. So it will be easy to see if T1 and T2 are a subset of S or not. And when you do that, we know how to expand binomial, this summation, and choose k and square root of 2 to the power k. So if k is even, you know it will be 2 to the power m, and if k is odd, this will be square root of 2 to the power m. Then you can write this k as, let's say this is my A and this is my B. So you can write this 1 plus square root of 2 to the power n as an expression of A plus square root of B. So from this you can tell T1 and T2 are a subset of S. So we know Z is a subset of S, T1 is a subset of S, T2 is a subset of S, which mean if you combine them all, that is gonna be a subset of and if you combine all of them, that is gonna be a subset of S. So the first one is true. Okay, so now let's look at 2. So we wanna see if the intersection this interval 0, 1 over 222 is the null set or not, or an empty set. So we basically wanna see, so n is an integer, we basically wanna see this range of our T1. So this is actually very easy. So we have this T1 is equal to minus 1 plus square root of 2 and okay, so we need to find the range of T1 and see, and then do the intersection of the with the given interval and check if it's a empty set or not, and that is easy. You know the square root of 2 is 1.414, and when you plug that in, and you will find out that this T1 expression would come out to be 0.414 to the power n, and we know n here is a natural number, and if you have a large natural number, then you will this is less than 1. So if you have a large natural number, this will approach 0. So there is some common, there is the intersection between the given interval, like it's not empty. So our option B is false. It's not a true statement. The option is also very similar. We're gonna try to find the range of this T2 and see if that has any common between this given interval, that is 224 to infinity, and you can do the same thing. We're gonna plug in the actual value of square root of 2 and you're gonna get 1.414 to the power n, and when n is a very large number, you gonna this gonna pass 2024. So there, this is not an empty set. But the intersection between T2 and the given interval not an empty set. So our C option is true. Okay, so so now option D is for a given AB, which is an integer. You have this expression cos of something plus I sine of something that is belong to an integer. That is an integer only if B is equal to 0, and where I is the square root of -1. This is a imaginary number. So this should remind you of Euler identity. That is this. And now you can you have this expression, and you can try to put this in an exponential form and see what we will get. Okay, so now we're gonna apply the Euler identity to the expression. We can see we get e to the power I pi multiply with a plus b square root of 2. And now we need to see when we plug b is equal to 0, then you're gonna get, when you plug b is equal to 0, so when you plug b is equal to 0, you're gonna get e to the power I pi a, and this you should know that you can write this as -1 to the power a, because e to the power I pi is -1. So now this tells us that this belongs to Z. So the statement is true, but we also need to check when b is not is equal to 0, what will we get when b is equal to. So when b is not is equal to 0, you're gonna get some so when b is equal to not 0, you're gonna get some irrational number multiply with pi, and we know angle irrational multiple of pi is not plus minus 1. So when b is not is equal to 0, this is not gonna be an integer value. So it's only true when b is equal to 0 that this expression is an integer value. So C option is correct. Yeah, so this was very easy. Like, I maybe took longer than what you would have taken, because I needed to explain it. You don't have to explain it to anyone, but one thing to always keep in mind that always read your question, and even if look very complicated, and if it's very long, the longer the question is, the more information you have. So always read your question and give your best. So this is one of such question where they put so many this symbols and expression that once you, even without reading the problems, you're gonna have this notion in your mind that you won't be able to complete it. But read the question calmly and try your best. So I hope you like this video. If you do, give it a thumbs up, and I will see you next time.